Okay, in this problem, problem 7 of homework 8, we're looking at shining a laser through the Mount Wilson telescope, which is a 2.54 meter diameter. And the question is what would be the angular spread on the beam? Well, the angular spread is solely due to diffraction at the aperture of the telescope. And so if we look at this as single slit diffraction, we've got d sine theta equals m lambda. That defines the angle out to, if m equals 1, that defines the angle out to the edge of the central maxima, right? So I'm going to go ahead and put in equal, I'm going to put in lambda, m equals 1, and I'm going to put in theta 1 here, so we know we're talking about the first one. All right, so we have lambda, we have d, and the question is, what is theta 1? What is the angular spread? You can also use the Rayleigh criterion to go at this. You get slightly different answers, but here we go. Theta 1 is inverse sine of lambda over d. Okay, inverse sine of lambda over d. So lambda is 633 nanometers, d is 2.54 meters, right? 633 nanometers, 633 times 10 to the minus 9 meters, 2.54 meters. Lambda divided by d is not, I would do this correctly, is not divided by 0. And then we need the inverse sine of that. All right, inverse sine. And you can see the inverse sine is almost equal to the sine for the actual number for very small angles. All right, so that's the inverse sine. Neglecting atmospheric, and angular, so this is in radians. So let's put it in degrees, just so you have that 1.42 times 10 to the minus 1.43. 43 times 10 to the minus 5. Is it a minus 5? Yes, minus 5 degree. Okay? So that's answer to part A. Part B, neglecting the atmosphere, how big would the beam spot on the moon be? Well, for that, I'm going to go back to theta 1 in radians was 2.49 times 10 to the minus 7th. All right, and so when you think about a problem like this, you've got the Earth, you've got the moon, right, and you're shining this beam at it. That angle out here at the end spreads out. That bit right there, if you're looking at the angle theta, none of this is anywhere close to scale, by the way. If you're looking at the angle theta, that edge of the triangle, if you're trying to draw a triangle to say how big is that side, that edge of the triangle, that distance is theta times the distance r out to the moon, right? So the radius of the spot, right, is theta 1 times the distance to the moon. So 2.49 times 10 to the minus 7 radians times 3.84 times 10 to the 8th meters. $3.84 8 meters. And so our distance to the moon times our angle in radians gives us 9.57 or 95.7 meters. Is the radius of the spot, right? And if you want to say size of the spot, people usually think in terms of diameter, and that would be 180, 190, 191.4. 191, right? 191.4 meters is the size of the spot on the moon. 2 footballs and fields in size. It starts off about 10 feet big, ends up 2 football fields big. All right, that's it for problem 7.